Now let's look at an example, worked out example. This is from your textbook. So we have 6 months, and we have the expected demand, the forecasted demand. Then in this example, we have number of production days for each month. Okay, some problems will give you the production days, some problems will just assume the same number of days for each period, especially if you're doing the production planning in quarterly intervals, like quarter 1, quarter 2, quarter 3. Quarters tend to have the same number of production days as opposed to months. So if your aggregate plan is on a time basis like quarters, you would not see production days. So you have to adjust your computations accordingly. If you have production days that changes from period to period, then you can divide that production days into the expected demand. So that will give you the demand per day. Now if you add up all of the demand, add up all of the production days, and you divide that production days into the total demand, so that will give you the average demand rate as 50 units. So if you want to produce at a constant rate, level production, you will set the production rate to 50 units a day. So that is the idea here. So the blue line is the forecasted demand, so it goes up and down. And here is the level production. So this gap, what you see here, is the excess production during low demand. So that will get accumulated into inventory, and it will be used during the periods where demand exceeds your production rate. Now, given these costs, so inventory carrying cost is given $5 per unit per month, subcontracting cost, average pay rate, this wage, $10 an hour, so $80 a day, overtime rate, above 8 hours. Now, labor hours to produce a unit is given as 1.6 hours per unit. This is a very important number that you have to understand. So labor hours is also called standard hours. This refers to how many units of labor is needed to produce 1 unit of the product. Okay, that's very important. And cost of increasing production rate, see $300 per unit. So if you set the production rate at 50 units a day and you increase it to 51, so that's going to cost you $300. The cost of decreasing, so from 50 units a day you want to decrease it to 49, so that will be at the rate of $600 per unit. So these are hiring and firing costs. In this example, it is based on number of units you increase and number of units you decrease. There are other examples where hiring and firing would be directly related to number of workers you have to hire and number of workers you have to fire. So depending upon how the problem is stated, you have to adjust your computations accordingly and compute those hiring and firing costs properly. Now here is the result of the constant production that we looked at. So 50 units a day. So if you produce at the rate of 50 units a day, 50 times 22, 50 times 18, so on, this is going to be your production. But these are the demands. So how much excess inventory or reduction? What is the difference between your production and demand? So first month you're producing 200 units more than what you demanded. So your inventory starts to increase. So 200. Next month also you produce another 200. So your inventory level goes to 400. And then the next month again you're producing 250 more than what you need. So inventory goes up to 650. The next month your production is 1050, but your demand is 1250 to 1200. So your demand is 150 units more. So your inventory now goes down, okay, down to 0. So these are the inventory levels that you will experience from January to June. So this is the amount of inventory for which you have to pay inventory carrying cost. So 1850 unit months. So this multiplied by the $5 I think. And workforce required to produce 50 units is 10 workers because you need 1.6 hours to produce 1 unit and you have 8 hours a day. So 8 hours divided by 1.6 will give you how many units one worker will produce and divide that into 50, you'll get 10 workers. We will work this out in just a few minutes. Then you do the computation. So 1850 carrying cost $5 a unit per month, and then regular time wages 10 workers $80 a day, 124 days, and this gives you the total cost for this plan. So this is your level plan. Now let's look at another approach. Suppose we want to set the production level to equal the lowest demand rate per day. So that way you will never have idle time, because at the very least you have to produce that amount. Now anything over that, let's assume that we're going to do subcontracting. So we'll maintain a level workforce at the lowest possible demand rate. And then anything over that would be subcontracted. If we want to follow that approach, we have to now look at the demand rate. So we made these computations a few slides back. So here is the demand and here is the number of production days. So you divide the production days into the demand and you get the demand rate per day. And you see that the lowest demand rate per day is 38. So if we set production rate at 38, and if you graph that, and this is what it will look like. So this is your demand that's given. Now you set your production rate at the lowest demand rate. So anything over that will have to be met by subcontracting the demand. Now we will compute the cost for this. So we're going to produce 38 units a day for 124 days. So that's the total number of units that we will be producing in-house. Remember, the total demand is 6,200. So the balance, which is 1488, will have to come from subcontracting. So here is the subcontracting cost, and to produce at the rate of 38 units a day, we need 7.6 workers, and then $80 a day and 124 days. This will give you the regular labor time. So you need to divide 8 hours divided by 1.6, the standard hours. 8 divided by 1.6 will give you how many units one worker can produce, and divide that into the required production rate of 38, and that will give you the number of workers, and here 7.6 workers are needed. You're not going to have 7.6 workers, but we need to have on the average 7.6 workers over the entire month. Now let's look at another approach, and this approach is the chase approach. So what we're going to do is produce exactly what is demanded. Okay, so here is the daily production rate that we calculated in previous slides. So we are not repeating that computation here. It will be like forecast divided by the number of days. So this is the daily production rate. Now you can multiply 1.6 hours per unit times $10 an hour. So you take 900 times 1.6 hours per unit times $10. So and add them up, so that will give you your production cost. Now you're going to do hiring and firing. So first month we'll assume that there is no hiring and firing. Next month, from 41 units a day you have to go down to 39. So there is no hiring or no increase in production, but there is a decrease in production rate of 2. So 2 times $600 per unit is the cost. Okay, so that's your cost. So adding this column and that column gives you the cost for the given month. And then March, from 39 you have to go further down to 38, so 1 unit. Then going from March to April you have to go from 38 to 57. So you have to increase the production rate, the daily production rate, by 19 units. So you have increase in production cost times 300. So there is no firing cost here. Now again we have to go from 57 to 68. So that's 11 units a day. And then the last month you're going down from 68 to 55. So if you sum column wise, you'll get the cost for each category for the entire 6 months. If you sum row wise, you get the total cost for each month. So sum these and you get your total cost for the entire plan. So this is the graphical representation of what we just went through. So your production is going to follow exactly the demand pattern. So here are the comparisons. Plan 1, which is level 50 units a day, and then plan 2 is to set the production at 38 units a day and use subcontracting. And then the plan 3 is chase. Now what we're going to do is I'm going to take this problem and make some few changes, because here we did not take into account what the previous production rate was. We just simply assumed that it is 50. So what if in the previous period the production rate was 45? So you'll have some hiring cost at the starting of the planning horizon, and there may be some additional inventory already available to us, initial inventory, or there may be safety stock requirements. So these are additional bells and whistles. So I'm going to add those, assume some numbers for those, and we'll work out a problem, and we'll also work out, we'll work two different problems, and each of them we will discuss the different methods.